Excellent. Yeah. So I'm just going to go ahead and jump right in. And I want to start this off with a question. And obviously, I wrote this before COVID-19, but in the chat, maybe just let me know how many of you like to just travel, forget everything, get on a plane, fly to the Caribbean or, to the UK or wherever. I think most of us really enjoy that experience, and it's a wonderful experience because you're working all week and all you're thinking about, you're writing your features or you're doing whatever at work, and all you can think about is how you're going to get on that plane. You're going to fall asleep, you're going to wake up in paradise. So you're rushing to finish the feature you're working on, and Friday afternoon, you cannot wait. 4 o'clock, you push your code out, you close the laptop, and you are out the door. And you get in your car and you drive to the airport, and you get there and you check in, and you're so excited, and your flight is canceled. Right? And it's the absolute worst feeling in the world. And in that moment, you aren't thinking about the software, right? You aren't thinking about the software that any of the airlines, Delta or American, are using. All you want is to get on your plane to get to paradise, right? And you just want the issue resolved. And that permeates, right? So a lot of us have an airline that we refuse to use, right? So a lot of people I know refuse to fly Delta or American, right? And we just won't use those because of issues like that, right? Canceled flights, delayed flights. And so what I want you to do is I want you to keep those bad airline experiences, and I think we've all had them, in mind. And what we're going to do is we're going to go through a few brief issues, and I'm going to show you some examples of when the business and engineering collide for an airline, and also maybe when one of those airline software engineers just couldn't wait to get on vacation and pushed a feature at 4 o'clock to just get out the door. And so we'll start in 2010. In 2010, Virgin Blue had to cancel 116 flights during a software outage that lasted 11 entire days, right? And in 2017, the British Airways canceled over 1,000 flights due to a software failure. In 2019, same thing at Heathrow Airport, there were 150 flights canceled due to a software flaw in their flight data processing system. And then finally, not to pick on British Airways, but their statistic shows up the most. Again, in 2019, check-in and flight departure systems had bugs, and it caused hundreds of flights to be canceled or delayed. And so that moment where bad code was pushed or something fell over resulted in a lot of people doing this, right? Sleeping in the airport, just waiting, not going home. Just an overall terrible experience, right? And so what I truly believe is we as engineers have an obligation to the consumers of the products that we build, right? And so a lot of times, even if you worked for one of these, airline API companies, right? You write APIs for ticket processing or whatever. How often have you ever thought about someone who had to sleep in the airport, right? But again, we do have an obligation to build quality products for our consumers, right? And I really believe that we as engineers, and that's any type, right? Reliability, quality assurance, software, have the power to bridge the gap, right, between business, which this is a business outcome, right? A bunch of customers who are incredibly unhappy. A lot of those previous failures were 20, 30, 40, $50 million bugs. And the engineering organizations. And what I believe is that observability is actually the tool which we can use to build that bridge, right? And what we can do with that is we can provide actionable insights. And what those insights will allow us to do is build and maintain better consumer relationships, right? And so to begin with this, we really need to define two terms. And this being an observability conference, I'm going to fly through this one, which is what is observability, right? And we've seen this one before from control theory. So I'm actually just going to skip that one and move on to the next one, which is this phenomenal quote from Charity Majors, which really distills the idea down into, can I ask new questions about my system from the outside and understand what's happening on the inside, right? Without shipping new code. And so observability at the end of the day is about making educated guesses, right? And there is a much more formal term for an educated guess, which is a hypothesis. And in a hypothesis, you are saying if something, then something will happen because of reasons, right? And if we look at those from the actual terms, that's if an independent variable, so that is what we are changing, right? Then there's a dependent variable, which is what we are measuring, right? And then the because there is the rationale. And the rationale is the research that indicates that our hypothesis or an educated guess is correct. The rationale is the thing that allows us to truly make an educated guess. And so observability is that rationale, right? Because what it does is provides you with the data to make the educated guess. And if you can't answer that question, then your system is what's considered inadequately observable. And what you have to do in order to remediate that is put instrumentation in place until you have the data to answer your hypothesis, right? And so this is a very, very, very old slide, actually. It's from Marissa Mayer, did a presentation at the Web 2.0 conference in 2006. And she showed this statistics, right? Which is that Amazon found that when they increased latency by 100 milliseconds, they lost 1% of sales, which is high impact, right? When we look at that from the lens of an engineer, we see that on the left, 100 milliseconds is an immediate thing that, oh, I can solve that, or I know where to look to kind of increase that performance, or that's a thing that I can handle. But the 1% of sales is typically a thing that we think of for the business to solve, right? Like, okay, so we lost 1% of sales. Okay. But what observability does is allow us to encapsulate both of those, right? Both the 100 milliseconds and the 1% of sales, right? So as an engineer, I can actually look at both of those together. And if we go back to the hypothesis framework, we can see that if I increase my latency by 100 milliseconds, then I'm going to lose 1% of sales because, and here I'm just using the term observability, but that means because of all the instrumentation I've done, because of the data that I'm collecting, I am now able to answer this question, right? So Amazon was, because of the instrumentation and the data collecting they had done, were able to post a slide or data like this, and that's their educated guess, right? More latency equals less sales. And so another way to frame the idea of observability is really to think of it as starting with or asking why. And there's this phenomenal book actually about business leadership by Simon Sinek. And this is called the golden circle, right? And what it means is start at the center and ask or answer why, and then think of how, and then think of what, right? And so typically from the outside, we think of what, but what we should be doing is thinking of why. Why does this thing occur, right? Why when we have this error do customers drop out of the funnel? So it's a very different way of thinking versus what, right? What is, the API has 200 extra milliseconds of latency, right? Very different framing from why are customers dropping out of our funnel. So The common thinking is that there are three pillars of observability, those being metrics, logs, and traces. But I disagree with that. I truly think that observability, again, with thinking about it as answering your educated guesses, is whatever it takes to answer those questions, right? So if they fall within those three, which they typically will, but if they fall outside of that, all that matters, again, is providing the data to answer the questions. So if we move into business value and what is business value, when you think about a business, the best way to view that business, truthfully, is as a network of relationships, right? So how do they interact with all the different parts of the business? And that is both internally and externally. And breaking that down into the two types of external and internal. From the external perspective, we have things like customer value, right? So the direct interaction with customers. You have your supplier relationships, the people that provide the goods that allow you to make what you make, right? The collaboration, so collaboration among multiple companies. We see that a lot in the open source. And then the impact on the wider market. So how does what we do change the market, right? And that's where you might think of like disrupting. From the internal perspective, you have people, so that's your employees, all the processes that wrap around how you provide business outcomes. And then finally, the technology that you use to accomplish those outcomes. So for this talk, I really want to focus in on the customer value, right? So the way that I want you to think about this is, business value in terms of the customer. And when customers make buying decisions or renewal decisions, right, you think about a couple of things. And the first one being cost, right? Do I feel like I'm getting my money's worth for what I've spent? The next one being quality, which is 99% of the time, or hopefully 100% of the time, depending on what you're purchasing, it operates exactly how it should. Service, though, is how does the business respond when it doesn't act the way that it should, right? So that means, thinking about a company that's really phenomenal at service is Dyson, right? If you pay out the nose for a Dyson vacuum, but if any piece of that breaks, they will send you a replacement piece without any questions asked for free. I hope they still do that. I haven't had to do it in a long time. But the final thing, which more or less encapsulates those other three as well, is past experience, right? So if Dyson has sent me repeatedly, I've had quality issues, but they've been amazing, right? They've replaced the stuff. They've been apologetic. They've done refunds, whatever it is. The past experience is going to educate my future decisions, right? In addition to the cost of quality and service, but that is where you build relationships over time, right? Which is the most important thing for the business, is building up those long-term relationships with customers. And these are the mechanisms by which you do it, right? So there's this phenomenal article by the ThoughtWorks folks, Ian Cartwright and Martin Fowler, right, called The Elephant in the Architecture. And the part that I took away from it the most is this quote, which is that business knowledge should be part of a technical career path. And what this really means is you don't need to go out and get an MBA, but you do need to understand how a business operates, because understanding how the business operates will make you associate the things that you're doing, right? The code that you're writing, the alerts that you're doing, the way that you test, all of that will be through the lens of business outcomes, right? How do I make sure that we are developing strong, long-term relationships with customers, and that when we do have failures, we're communicative, we quickly repair them, right? All the things that, if you put yourself in the shoes of a consumer of your business, those are the things that you would be looking for, right? So I want to take and kind of do a little bit of a thought exercise, which is failure through the lens of observability, right? And I want to present to you guys a hypothetical company called Acme Logistics, right? And they are a trucking company, nationwide trucking company. And what they do is they pick up goods and they take them and they deliver them to others, right? So customers request them to come pick up their goods, and then they are delivered to the receiver. But I want to look at this through two separate lenses. And the first lens is a company that is barely, if at all, on their observability journey. And then I just noticed Liz has her video on now. Now I'm starstruck. The first one is through the lens of a company that is very early on or barely at all on their observability journey. And the second company is a much farther along. So the same company, Acme Logistics, but much farther along on the observability path. And so I'm sure that a large number of you have been on call before and woken up in the middle of the night. So apologies if this brings up any prior emotions. But I want to put you in the shoes of an on-call engineer for Acme Logistics. And from the first, again, going back to the company that is just, they're not there yet, right? They have basic up-down monitoring or barely observing the system. And it's 3 o'clock in the morning, right? And you get a page and you roll over and you check your phone and there's your error message. CPU usage is high on production infrastructure 01. And so you sigh, you roll out of bed, and as you do that, other alerts begin to fire. CPU usage is high on production infrastructure 02, 03, 04, and of course, 05, and that is your entire production infrastructure. So you get your laptop out, you pop open the terminal, and you do some cursory poking around, right? And it looks like it's the Docker process, but it's on every machine. And so you do what you always do when you have an issue at 3 o'clock in the morning that you can't solve, which is you open up a conference bridge and you get on the phone and you begin to call other engineers to get them involved. And the conversation goes a little like this. Hey, what's up? CPU usage is kind of high on all of our production machines, and I'm not sure why. And it kind of looks like it could be Docker, but it's impacting all of production. Do you have any thoughts? And what happens whenever you crowdsource suggestions is they're going to come at you rapid fire. And some you've tried and some you haven't. And you continue to add people or other people add people onto the call, and it becomes disorganized chaos, right? People arguing, people suggesting, other people in the machines trying to debug with you, and you still don't have any answers. And the investigation continues to drag on, right? And others are joining the call and they're being caught up to speed. You have developers getting in, your on-call other SREs, whatever it is, they're everyone's talking and everyone's troubleshooting. It's incredibly hard to concentrate. And then you hear the beep that someone else has joined the conference bridge and everyone goes quiet. And it's the vice president of infrastructure. Yeah, I just got a call from Larry over in trucking support. He said they're getting hit with a ton of calls from drivers who are unable to get their documents to load to make deliveries. What's going on? And of course, you reiterate the same thing that you've reiterated before. CPU usage is high on all of the production boxes, and Docker's going crazy, and we're not sure why. Well, how many documents are you unable to send? What's the impact here? Is it all of them? Do we have anything to help Larry communicate with the drivers and let them know when they can make deliveries? And that is the moment when you know it's going to be a long night and or a very early morning. So if we look at this from the lens of a company, again, much farther along on their observability journey, you're again an on-call engineer, and your warning actually comes in at 3 p.m. the previous day. And that warning says failed delivery rate is elevated in region Northwest, right? And so you begin to investigate. But cognitively, it's pretty easy, right? So there's a couple of things that you can immediately take from this alert, which is very much business outcome focused. First of all, I understand where it's occurring, right? I understand that it's in the northwestern region of the United States. And I also understand that deliveries are failing in the northwestern region of the United States. So I already have that going for me. So as I begin to dive into the data, I'm looking at the errors and I'm kind of seeing where they're originating from. And all of the errors are coming out of this one single terminal hub. And these terminal hubs are responsible for uploading these documents. And also they're the dispatch for all of the trucks, right? So that's where the trucks come and they grab the things that need to be delivered to their associated delivery locations. So I know that this terminal is a problem. And so as I look into it, the flow here is that the terminal hub updates these documents and then uploads them, right? And when the drivers get onto their iPads or their remote devices, when they make deliveries, they download the updated documents to be able to present so that the person can sign that they've received it, right? And get invoiced. And as you're diving in, you notice that these errors or these documents, which have metadata on them, all are of a certain size, which is over a gigabyte. And because you can compare that to the normal size of a uploaded document, a gigabyte is 10x, 100x larger than the normal shipping document. You also notice while doing this investigation that when one of these documents is sent in and ingested, that CPU usage jumps, right? So the real value here is not in all of that, which is why I didn't go in and break this down, showing you guys screens in Jaeger. The value here is the conversation. And so as you're investigating, you know that this, again, affects the entire Northwest, right? It affects the Northwestern terminal hub. Delivers are the orders that are erroring are causing drivers to not be able to make deliveries. And so because we've been able to identify this at 3 p.m., right, you are able to proactively reach out, which sounds a little like this. So you pick up the phone and you call Larry in trucking support. Hey, Larry, I got an issue here that's going to absolutely have an impact on West Coast drivers making their deliveries. Drivers are unable to retrieve documents that are uploaded by a specific terminal hub. And what it looks like is that hub is sending us overly large documents, like way above the normal size they usually upload. And it's causing increased document retrieval times for other drivers, and there is some system impact. The hub's pretty low traffic right now, but they do the majority of their transactions overnight from around midnight to 4 a.m. So that impact is going to grow. Now Charity Major's in here. It's getting better. Larry reaches out, contacts the hub, and it appears they've had a glitch in their third-party transportation management software that's causing malformed documents to be uploaded. So the third party is going to fix it immediately, and the hub is going to reach out to the drivers to let them know the impact. And so you get a call back from Larry, and he thanks you profusely, right? This could have affected all deliveries for the Northwest, right? And so that night, framing this much farther on the observability journal, you sleep very well. So what truly makes this company different, right? It's the same company, but through this secondary lens. And so the second company is much more of a modern data-driven organization. And by data-driven, I mean that they make educated guesses based on data. And the hypotheses or questions that they ask are all about end user outcomes, right? That's their total focus. What is it like for the end user? In this case, the customer is the driver, right? The driver is having a bad experience. And so they are the end user in this case. From a development perspective, code is instrumented with granular high cardinality metadata. But what's important about that is that this high cardinality metadata is, again, business outcome focused. So only really instrumenting the things with high cardinality that you really do need to slice and dice that are going to affect a driver making delivery, a terminal hub not being able to process shipments. From a QA perspective, the QA team rigorously tests their high value features. And the way that they do this is by real user usage. But that means that let's say you're working on a feature that's going to go out to 30,000 users, that's going to get 300 hits a second or something like that. That's a high value feature, right? Or one, moreover, that processes $20 million a day in revenue. QA in that point can then justify, we really need to rigorously test this feature because we know the impact, we know who it's going to affect, we know how much it's going to affect them. And then finally, from the SRE perspective, the alerts that are written are actionable and they directly apply to end user outcomes. So going back to that first one of CPU usage is high on a machine, great, right? That's something that, okay, we've all responded to an alert like that before. And at 3 o'clock in the morning, trying to really process what high CPU usage means is not easy. But at 3 o'clock in the morning, I haven't tested this, but at 3 o'clock in the morning, we're getting an alert that says, all driver deliveries for the Northwestern hub are currently impacted, right? Drivers are unable to make deliveries. That allows me to think immediately about the customer outcome. That shows importance to me, right? I'm not worried about okay, I know what my blast radius is from the alert. And so it really changes the conversation, the perspective of how you look at those alerts, because you're responding to a literal customer outcome, right? So all sounds great, right? It always does, but how to do it? And I think the first thing is to just understand you can't boil the ocean. And the perspective to take here is literally going back all the way to this idea of this hypothesis-driven development or hypothesis-driven observability, which is I have a problem and I need to see if I have the instrumentation to answer it. So a good example of this is actually technical debt. So we all have technical debt, everyone has it, and in a less modern or a less company with a lot less observability, what occurs is all technical debt gets bubbled up with the same amount of priority, and you're going typically on developers' gut reactions to how to respond to it. And so there's no weight to it. But with observability, if you believe that the technical debt that you really want to fix is important, instrument, right? Just instrument it and then find out who's using it, how are they using it, and what's the impact. And that allows you to and it might be eye-opening. What might happen is the thing that you thought was incredibly high priority to fix turns out to affect 0.01% of users on an API that barely gets any traffic to it, and it doesn't really matter. Or the thing that you thought was very low priority actually can increase performance, 200, 300% for a very high traffic API. The next thing is truly to speak to the business. And that doesn't just mean business leadership. If you have that channel to be able to speak directly to the business leadership, that's fantastic. But this is all the way down to salespeople. So salespeople are fantastic people to talk to because they directly interact with the customer and they want to make their commission, right? And they want to retain customers because that means more money for them. And so understanding what keeps customers from coming back and how they truly feel about the product is very important, right? So that's a really easy way to directly see customer outcome to features or code that is written. And the other big thing with that is just to listen. So in this case, you need to just listen to what they're saying, right? And there is always going to be that snap reaction of, well, I wrote this thing, it's perfect, right? But These are true customers. They're telling, that's how they feel. Plenty of us have had a bad experience, again thinking back to the airlines, and you'll never use that airline again, and that's one less customer. And you don't want to be the one that wrote the feature that causes a customer to never use the product again. And that dovetails really nicely into this, which is, remember those people in the very beginning who missed their flight, right? So think about end user outcomes in your work. And when you're writing or when you're writing an alert or whatever it is, think about the person that's going to be using the thing that you're doing, right? And how that would affect them if there's a bug or an outage. That's a really easy way to frame it. And then finally, if you can't answer a question, instrument, right? So this is all going back to it, which is that you want to be able to rationalize your educated guesses. And the way that you rationalize your educated guesses is by having the data to allow you to do so. And so instrumentation is very important, and it can be very pointed to answer those questions. So I want to end this with two final quotes. One of which is, if you don't learn to sell, you're always going to be working for someone who does know how to sell. And I think breaking this down, this doesn't mean going door to door selling vacuum cleaners. What this really means is selling your ideas, right? So observability, again, is the path or the tool by which you are able to sell your gut feelings to the business, right? It no longer is a gut feeling. It is, you're coming to them, right? And you're saying, for instance, the technical debt, I want to really fix this technical debt. But here's the data, and also here's what I think will happen if we do this thing that I'm recommending. It completely changes the narrative away from the typical engineering as a cost center, depending on your organization, into here's the immediate value add for the business: better performance, better retention, higher customer satisfaction. And so finally, to come right back to this again, business knowledge should be part of a technical career path. Understand business outcomes, and the code that you write and the things that you instrument, everything should be modeled around the direct impact to the customer or indirect impact to the customer. Learn how that relationship works and how the things that you write and the things that you do help to strengthen those business relationships. So I see I'm a little bit over time, but thank you so much. And I will be available in Slack to answer any questions you guys might have. And again, amazing job, Paul. Thank you so much.